Hello. All right. So last night you guys watched an Edpuzzle video, and it went over numbers 9, 11, and 12 from solving fractional equations or solving rational equations. So what we're going to do today is we're going to continue on with that. All right. So what we're going to be doing, the regular Algebra 2s and the lab classes are going to be doing number 18. We're going to start with that, and then we're going to do these three problems, 10, 13, and 14. The accelerateds are going to do the same problems. Okay, they're going to start with 18, and then they're going to do 10, 13, 14, but you're going to do an additional two problems. You're going to do numbers 15 and 16 as well. All right, so let's get started. So we're going to do number 18 together just to kind of review what you watched in last night's Edpuzzle video. Okay, so number 18, it gives us an equation right here, and it says that to solve, Ren multiplied both sides by the least common denominator. Which statement is true? Now, I'm looking at all of these answers here, and it says extraneous solutions, okay? A lot of them contain the words extraneous solutions. Now, if you remember, an extraneous solution is an actual solution that you get when solving this problem that we actually have to eliminate because it doesn't work for some reason or another. So if you have a fractional equation, the reason why one of your solutions wouldn't work is because it would create an undefined fraction. It would create a zero in the denominator of the fraction. So for example, see how this denominator says x minus 2? If we replace that x with a 2, wouldn't 2 minus 2 be 0? And you can't have 2 in the denominator of a fraction. Okay, and just like here, see how this is just an x? If we replace this x with a 0, that would create a 0 in the denominator, and you can't have a 0 in the denominator of a fraction. So some of you might be looking over here at choice number 3 and saying, oh, look, 0 and 2 are extraneous solutions. Now, I just want to give you a heads up. You can't just jump right to saying that because we don't know if these are the solutions we would have gotten if we solved the problem. So we first have to solve the problem, see what the solutions are, and then eliminate any roots that would create a 0 in the denominator. Okay, so let's go for it. Okay, so I rewrote this to give myself a little room. Now, we know the first thing we want to do is we want to find the common denominator. So this has an x minus 2. This has an x, and this right here, this can be factored. If you have something that can be factored, you want to factor that first to help you find the common denominator. So if I look at both of these two terms, I can pull out an x from both of those two terms, which would leave me with x minus 2. Okay, so I'm going to get rid of this. So now, here I have an x minus 2, which is contained in this denominator, and here I have an x, which is contained in this denominator. So x times x minus 2 is going to be our common denominator. Okay, so what I did was I rewrote each of these denominators with the common denominator. Okay, so now let's look back at our original fraction. You want to say, what is this original denominator missing that the common denominator has? Well, it's missing this x. So let's put it there. Let's put it down here in the denominator. And if we put it in the denominator, we also have to put it up here in the numerator. Okay, so on the top, we have, I'm just going to leave it like it is, as x times 2x. I'm just going to put the 2x in parentheses instead. It doesn't matter. Okay, now we want to look at our second fraction and say, what is this denominator missing that our common denominator has? Well, it's missing this x minus 2. So let's put it there. And if we put it in the denominator, we also have to put it in the numerator. Okay, so for right now, I'm just going to leave this alone. I'm just going to bring it down as 11 times x minus 2. We'll worry about distributing later. And then we want to look at our last fraction and say, well, what is this denominator missing that our common denominator has? Absolutely nothing. So we don't have to put anything in there. So I'm just going to take this numerator of an 8 and bring it right down. Okay, so our first step was finding the common denominator. And you know you have to multiply top and bottom of a fraction by whatever it's missing from the denominator. Okay, so now that all of these denominators say the same exact thing, we could just take them and cross them right off. So this equation that we see here, I'm just going to kind of circle it, is what we need to solve. Okay, I'm going to first rewrite it because I don't want to mess up distributing anything. So we have x times 2x minus 11 times x minus 2 equals 8. Okay, so I'm going to distribute. X times 2x would be 2x squared. Now this is a negative 11, so we're going to distribute a negative 11 inside the parentheses. So I like to draw these little arcs. Negative 11 times x is negative 11x, and negative 11 times negative 2 is positive 22. And then I can bring down the equals 8. All right, let me give myself a little more room. So this is what we're solving. Now we know whenever we have an exponent, we want to get one side of the equation set equal to 0. So I'm going to subtract 8 from both sides of the equation, and that'll leave me with 2x squared minus 11x plus positive 14 equals 0. Okay, and now from here you can either, you could do one or two things. This is a quadratic. If you want to write a quadratic as where your biggest exponent is an x squared. If you want to use the quadratic formula, you can. Or we could just factor. So I'm going to factor. So since our leading coefficient is a number other than 1, we know we're going to have to do the rainbow. So when we do the rainbow, we bring down the first term, we leave a bigger space, and we bring down the last term. And don't forget about this equals 0. And then we just come up with two numbers that multiply to the rainbow number. So multiply to 28 and add to negative 11. All right, so that's going to be negative 4 and negative 7. So negative 4 and negative 7. And since this middle term contains an x, we need to put an x on each one of these two terms. All right, so now we're going to group. So when we group together the first two terms, we could pull out a 2x, and that's going to leave us with x minus 2. And when we group together the next two terms, well, you could either pull out a positive 7 or a negative 7, but let's think about it. If we want to be left with a positive x and a negative 2 in parentheses, you're actually pulling out a negative 7, because negative 7x divided by negative 7 is positive x, and positive 14 divided by negative 7 is negative 2. All right, so we're almost there. So now we're going to take this 2x and the minus 7, and we're going to group them together. And we're going to rewrite our x minus 2 just once. And don't forget, you have to have this equals 0 the entire time. Okay, if you start off with an equation, you have to end off with an equation. All right, and then we're just going to make our t-chart. So over here, I'm going to set 2x minus 7 equal to 0 and solve it. Okay, just add 7 to both sides of the equation and divide by 2. So that gives me x equals 7/2. Okay, now over here, I'm going to do the shortcut. We could look at this one and say x equals positive 2. All right, so these are the two values we got. We got 7/2 and we got positive 2. Now, if you recall, the question was talking about extraneous roots. So let's take a look at what we have up here. Okay, and remember before when we said 0 and 2 would both create zeros in the denominator of the fraction? Well, 0 wasn't one of our solutions, was it? See, this was a solution and this was a solution. So it can't be choice 3. Okay, that one's out. All right, now let's look at the other ones. We did say that 2 is an extraneous root, right? If we plugged in here 2 minus 2, that would create a 0 in the denominator of the fraction. So 2, this definitely is an extraneous root. So it looks like choice 1 is going to be the answer, because here, 7/2 isn't the extraneous root. If you substitute in 7/2 for any of these x's in the denominators, it's not going to create a 0 anywhere. And then choice 4, this equation does not contain any extraneous roots. That's not true, because we already know 2 is an extraneous root. So choice 1 is our answer. Okay, so what I'd like you to do at this point is, if you're in regular Algebra 2 or a lab class, I'd like you to do these 3 problems on your own, and then you can watch the video to see how you did. If you're in accelerated, I'd like you to do these 5 problems on your own, and then you can watch the video to see how to do numbers 10, 13, and 14, and then you could check your answers with numbers 15 and 16 on the answer key under Unit 3 answer keys. All right, so one like number 10, when you look at the denominators, this one's always tricky for people to come up with a common denominator. A lot of people look at it and say, oh, look, I'm going to make it y minus 1. I can just subtract 1 from the bottom and the top of this fraction. But you can't subtract to the top and bottom of a fraction. That changes the value of the fraction altogether. You have to multiply the top by something and multiply the bottom by something. So I try to take a look at it like this. I say, if we see it contained within any of the denominators, we need to include it in our common denominator. So if we look at this first denominator, we have a y minus 1. Since we have it in our denominator, we need to include it in the common denominator. So I'm going to take a y minus 1 and put it in all of those. I'm rewriting these denominators in all of those denominators. Okay? If it's in any of them at all, you have to include it. All right, now let's look at the next fraction. This has just a y. And remember, there's nothing you could multiply a y by to get it to say y minus 1. So since this is in one of the denominators, we have to include it in our common denominator. So what I'm going to do is I'm going to put all of these y minus 1 in parentheses and just throw a y right in front of them. Okay, so now we look at our third fraction, and this says y minus 1. Well, look, we already have that in the denominator, so we don't have to include it. And then, really, I should have taken this 1 and put it over 1, right? So this denominator has a 1. Now, technically, isn't there a 1 in front of each of these y's? So it already is in our common denominator. So y times y minus 1 is going to be the common denominator. Okay, so now what we're going to do is we're going to look at, let me give myself a little more room. We're going to look at all of these original denominators and say, well, what is this denominator missing that the common denominator has? Look, this has the y minus 1, but it's missing the y. So what I'm going to do is I'm going to put a y in the denominator. And if I put that in the denominator, I also have to put it in the numerator. So up here we have y times y, which if you want to jump right into writing y squared, you can. I'm going to leave it separate for right now. And if you notice, I put my parentheses around the second y instead of the first. That doesn't matter. All right, now if I look at my second fraction, this has just a y, which is in the common denominator, but it's missing this y minus 1. So I'm going to multiply top and bottom of the second fraction by y minus 1. I'm going to change colors just so we could not confuse what's in each fraction. Okay, so in the second fraction, the denominator now says y times y minus 1, just like in the common denominator. And on the top, we have an 8 times a y minus 1. So I'm going to put that 8 times y minus 1 on top. Okay, let's look at the third fraction. The third fraction has the y minus 1, but it's missing this y. So I'm going to throw a y in the denominator, okay, as well as in the numerator. So on the top now we have 1 times y, which is just 1y. Or I'm just going to put y. That's the same thing as 1y. And then when we look at our last fraction, this denominator has a 1. It's missing the y, and it's missing the y minus 1. So we need to put that y as well as y minus 1 in the denominator. And if we put it in the denominator, we also need to put it in the numerator. So now, when we rewrite a numerator, we have 1y times y minus 1. Or just y times y minus 1. All right, so now we look and say, look at this. All these denominators say the same exact thing. So I can just take them and cross them right off. All right, so what I'm solving here, I'm going to, again, just rewrite this so we don't mess up with distributing. Okay, this is the equation that I'm solving. Okay, so let's go for it. I'm going to move this up and give myself some room. All right, so y times y is y squared. And now I'm going to distribute this negative 8 to both terms. So negative 8 times y is negative 8y. And negative 8 times 1 is positive 8. And then I'm going to bring down the plus y, bring down the equal sign, and then distribute. Y times y is y squared. And y times negative 1 is negative y. Okay, now we know when we have exponents in our equation, right? We want to get everything to one side of the equation. All right, so look what happens here when we do. So I'm going to actually take these two terms and move them to the left. So I could subtract this y squared, and I'm going to add the y. Okay, so again, I'm going to subtract the y squared, and I'm going to add the y. Okay, so on the right-hand side, it leaves us with 0. On the left-hand side, actually, the y squareds cancel off. And then I'm just going to combine my like terms. So negative 8y plus y, right? I can combine these three terms. It'll give me negative 6y. And then let me just take this plus 8 and bring it down. Okay, now to solve this, I'm just going to subtract 8 from both sides of the equation, which leaves me with negative 6y equals negative 8, and divide by negative 6. So I'm left with y equals negative 8 divided by negative 6 simplifies to positive 4/3. Okay, and if you plug in your calculator, negative 8 divided by negative 6, it'll give you this decimal, right, that keeps going and going and going. Please don't round and write 1.3 on your paper or 1.3 bar, right? We don't use that anymore. You want to be able to, you want to get an exact answer that you could substitute back in and see if it checks out. Now, in this case, I definitely, every time you have any sort of fractional equation, let me cross this off too. I want to make sure you realize we don't write that. Anytime you have any sort of fractional equation, you want to make sure that your answer, right, y equals 4/3, you want to make sure that it doesn't create an undefined fraction. So I'm going to go back to my original fractions and say, well, if I substitute this y with 4/3, is this denominator equal to 0? No. If I put 4/3 here, is the denominator equal to 0? No. And it isn't if I put it here either. So what that means is 4/3 is good, okay? That is going to be our answer. And if you definitely check to make sure this is right, which I always, I'm a fan of doing, in your calculator, you can take x and store it as 4/3, and then you would just basically plug this entire left-hand side of the equation into your calculator and hit enter and see if it checks out to give you 1. If it does, then you know you did it right. Okay, the next one we were taking a look at was number 13. Now, first thing we want to do is we want to find a common denominator. And, if you look at this denominator here, this denominator can be factored. If any denominator can be factored, you want to factor it first, just, to help you find the common denominator. So this denominator factors to x minus 4 times x plus 3. Okay, in order to factor this, you want to come up with two numbers that multiply to negative 12 and add to negative 1, so negative 4, positive 3. And a little trick, a lot of times it's a good idea, to look at the other denominators, because a lot of times those denominators are the factors of your third denominator. Not always, but it's just a little trick that can, help you out with factoring. Okay, so we can clearly see here that all of our denominators, right, we have an x minus 4 here and here, and we have an x plus 3 here and here, and there's nothing else contained in any of those denominators, so our common denominator is going to be x minus 4 times x plus 3. All right, so I just rewrote all of these with our common denominator. All right, so let's look at our first denominator. It has an x minus 4, okay, but it's missing that x plus 3 that the common denominator has. So let's take an x plus 3 and put it on the top and bottom of this fraction. I probably should have put it on the other side because this is a tight squeeze. Okay, so now we have x times x plus 3 on the top. So let me put that on the top up here. And we have our common denominator on the bottom. Okay, let's look at the second fraction. The second fraction has the x plus 3 that our common denominator has, but it's missing this x minus 4. All right, so let's put the x minus 4 in the denominator. And if we put it in the denominator, I'm just going to slide it here. I also have to put it in the numerator. Okay, so now our numerator has 1 times x minus 4. And then our last fraction, it has everything contained in the common denominator, so we don't have to change this fraction. So I'm just going to take the numerator and bring it right down. All right, so now that all of our denominators are the same, we can cross them off, and we're going to solve the equation that we're left with. The reason I always like to rewrite it is because a lot of times, if you don't, I find that a lot of people forget to distribute this negative to both terms. So when you rewrite it, it's clear that you're distributing a negative 1 within the parenthesis to both terms. Okay? If you can do that without having to rewrite it, go for it. But I find, it just makes it easier for most students. Okay, so x times x is x squared. X times 3 is 3x. And again, here we have a negative 1. So negative 1 times x is negative x. And negative 1 times negative 4 is positive 4. And you can bring down the equals 28. Now, because we have a squared in our equation, we want to get one side of the equation set equal to 0. So I'm going to subtract this 28 from both sides of the equation. Okay, so on the right-hand side, it leaves me with 0. Now, on the left-hand side, I'm just going to combine my like terms as I go. So this x squared doesn't combine with anything, so I'm just going to bring it down. This positive 3x and negative x combined to give me positive 2x. Okay, again, all I did was I just combined these two like terms. And then positive 4 minus 28 is just negative 24. Okay, so from here, I'm just going to factor, make a t-chart, and solve. So since I have a 1 in front of my x squared, and at this point, factoring should be no problem, okay? We've been doing this all year long, so, you know, if you still are having trouble with it, just keep in mind you can always watch the other videos to help, you know, reinforce how to do this. All right, so I'm going to set up 2 sets of parentheses, and don't forget to bring down the equals 0, right? We have to keep it in equation. And since this is an x squared, I'm going to put an x in the first spot in each parenthesis, and then I'm just coming up with 2 numbers that add to positive 2 and multiply to negative 24. All right, so that'll be positive 6 and negative 4. All right, and then we make our t-chart, and we get x equals negative 6, and we get x equals positive 4. Now, before I circle these answers or box them off, I just want to make sure that none of them create an extraneous, that none of them create an undefined fraction, okay? Because if they do, we cross them off and we write this is an extraneous root. Although it was a solution to the problem, it created an undefined fraction, so we can't use it. All right, so let's start with the negative 6. If I take negative 6 and substitute it in here, negative 6 minus 4 is not 0. All right, negative 6 plus 3 also is not 0. Here, negative 6 squared minus 6 minus 12 is not 0. It does not create a 0 in any of the denominators, so this answer is acceptable, so we're going to circle it. Okay, now let's look at this one, x equals 4. If I substitute in 4 for this x, 4 minus 4 is 0, and we are not allowed to have 0 in the denominator of a fraction, so this one we can't have, okay? We're going to have to cross that off, and I like to write extraneous root next to it. Although it was a solution to our problem, it's an extraneous root, one that we cannot use because it creates a 0 in the denominator of the fraction. Okay, and then finally, let's just take a look at number 14. Okay, so when you look at number 14, you could see this right here can be factored. Okay, so I'm going to jump right into factoring that. So that's going to factor 2 numbers that multiply to negative 10 and add to positive 3 would be positive 5 and negative 2. So x plus 5 times x minus 2. Now, if you look, this says x plus 5, and so does this. This says x minus 2, and this says 2 minus x. So think back to what we learned yesterday. We learned that you're allowed to switch the order of this, right, to make it say x minus 2, as long as we change the sign in front of the fraction. So since that's a minus sign, we're going to change that to a plus. Okay, so we kind of did a double change. We changed our subtraction to an addition, and we changed the order of this. And now we can see our common denominator is going to be x plus 5 times x minus 2. Okay, there's nothing else that's involved in any of these denominators other than that. All right, so same thing we've been doing for the others. Look at this original denominator and say, what is this missing that our common denominator has? It's missing the x minus 2. All right, so I'm going to put the x minus 2 on the top. And I'm going to slide it over here because I'm kind of running out of room. And I'm going to slide it on the bottom. Okay, so our denominator now has the x minus 2 and the x plus 5. And in the numerator, we have 4 times x minus 2. Okay, that's a minus sign there. So 4 times x minus 2. Okay, and in the second fraction, it has the x minus 2, but it's missing the x plus 5. So I'm going to multiply the top and bottom by x plus 5. Again, it's kind of squished in there, but I'm doing the best I can. So on the top, we have 6 times x plus 5. All right, and then this last fraction, the denominator, already is the common denominator, so we can leave this numerator alone. We're just going to bring it right down. Okay, so now now that all the denominators are the same, I can cross them off. And then this is the equation that I'm going to solve. Now, to be honest with you, because there's a plus sign here, I don't really care if you rewrite it. You can just jump right into distributing if you want. Or if you just want to be consistent, you can rewrite it and then distribute, whatever you prefer, whatever, makes it easier for you. Okay, so 4 times x is 4x. 4 times -2 is -8. 6 times x is 6x. And 6 times 5 is 30. And then I'm going to bring down the equals 4. Okay, so now we don't have any exponents. I mean, it's x to the first power, so it's not like we have to get one side of the equation set equal to 0. That's only if you have x squared, x cubed, whatever it is. So here, I'm just going to combine my like terms. So 4x plus 6x is going to give me 10x. And then -8 plus 30 is positive 22. And I'll bring down the equals 4. Okay, so we're just trying to get the x all by itself. So I'm going to subtract 22 from both sides of the equation. So that'll give me 10x equals, oh, you know what? Hold on, look at this. I didn't even notice this. This isn't a 4, this is a 14. Okay, so there we go. So 10x equals, well, 14 minus 22 is -8. And then when I divide both sides by 10, I get x equals, now this simplifies to -4/5, okay? If you prefer, you can also write -0.8, right? 4 divided by 5 is 0.8. It's a decimal that stops, so you are allowed to write it as a decimal if you want. Now, the only thing I have to do is I have to go back and make sure that if I substitute in this fraction or this decimal into the denominators, it doesn't create a 0. Okay, so if I plug in -4/5 for x here, -4/5 plus 5 is not going to give me a 0, so that's okay. I'm going to go to the original fraction. 2 minus -4/5, that's not going to equal 0 either. And if you try to plug in -4/5 in for both of these x's, I mean, technically you could just plug it in for these x's. It's also not going to give us a 0 anywhere, so -4/5 would be our answer. Okay, at this point, the regular and lab classes, you guys are done. The accelerated class, I'd like you to try out number 15 and 16 on your own, and then you could check with the answer key.